next we have division by t. Laplace transform of function f of t when it is multiplied by 1 by t, or you can say when it is divided by t, whatever you would like to call it. So this is what we will do next. So suppose if the Laplace transform of this function f of t, this is capital F of s, then in that case the Laplace transform of the function f of t divided by t, this is equal to the integration of from s to infinity of f of s ds. So note here that whenever you multiply your function with f of t, you would take its derivative, and when you divide by t, you will perform the integration. So you could remember it like this. So suppose we have this question. The question is, find the Laplace transform of sin t divided by t. So its Laplace transform would be, firstly what we'll do, we'll calculate the Laplace transform of sin t. So what is the Laplace transform of sin t? This is nothing but 1 divided by s square plus 1 square. So that is 1 upon s square plus 1. So this is f of s. So now the Laplace transform here of this term, this would be integration from s to infinity. Note here that it is not from 0 to infinity, but from s to infinity. So s to infinity of the function f of s ds. And what is this f of s? We just have it calculated over here. It is s to infinity 1 divided by s square plus 1 ds. So what would be its integration? Its integration would be tan inverse s, and the limits varies from s to infinity. So now whenever you have this limit as infinity, you would not directly substitute it. You will write limit b going to infinity tan inverse b, and then minus of tan inverse s, the lower limit. So now what is this first term? The first term, tan inverse of infinity. At what angle tan is infinity? At the angle pi by 2. Yes, at the angle pi by 2 it is infinity. So we have pi by 2 minus tan inverse of s. So this is the answer. So let us have one more question. So question number 2. It says that find the Laplace transform of 1 minus cos t divided by t. So for that, firstly what we will do, we will calculate the Laplace transform of 1 minus cos t. So it would be the Laplace transform of 1 minus the Laplace transform of cos t. And what is the Laplace transform of 1? It is 1 by s. And the Laplace transform of cos t, it is s divided by s square plus 1. So let us call this as capital F of s. So now in order to calculate this Laplace transform of 1 minus cos t divided by t, what we'll do, we'll perform the integration from s to infinity of the function f of s ds. And what is f of s? F of s is this quantity. So let us substitute it here. So it would be 1 by s minus s upon s square plus 1 into ds. So when you calculate the integration for this quantity, it would be log of s minus 1 by 2 log of s square plus 1. This quantity is obtained when you substitute this as some other variable, and then its derivative would be 2s ds. So when you substitute, for example, s square plus 1 by some other quantity, say m, then its derivative would be this term. So that means you have s ds as dm by 2. So this quantity, this term, that would become this s ds would become dm by 2, and then this quantity 1 by s square plus 1, it would become 1 by m. So that is why you have this quantity, and here the limits varies from s to infinity. So now here you see we have this log term. So how can you solve this log term? You cannot directly substitute the limits. So you can combine this term. So we would have log of s divided by, what would be this term? This would be s square plus 1 square root, using the properties of log. We have log of m minus log of n, that is equal to log of m divided by n, and moreover if you have some quantity m log of n, so that is log of n raised to power m. So these properties I have used here. So this term becomes s to infinity. So now also you cannot directly substitute the limit, because here when you substitute log of infinity divided by infinity square plus 1 square root, so this won't make any sense. So what we do instead is, whenever you have terms like this, so for the first quantity you will just write this to be log of, you divide everything by s. So you have s divided by s in the numerator, and in the denominator you would have square root of, when you have when you divide this by s, and when you take this s inside this square root, you would divide that by s square, so it would be s square plus 1, right? And the limits varies from s to infinity. So now you could substitute the limits, because this term would be 1, so we would have log of 1 divided by, this term would be square root of 1 plus 1 by s square, 1 by s square, and when you substitute s as infinity, this term would be 1 by infinity, and 1 by infinity would be 0. So ultimately this term would be 0, right, when you substitute infinity, and minus of ln of this term 1 divided by square root of 1 plus 1 by s square. So here this, from here we get log of 1, and from here what is this? You can rearrange it. So you will again have this term log of s divided by square root of s square plus 1. So this step is required because you cannot directly substitute the limit tending to infinity. So you have to first divide by s in order to substitute this limit. And now we know what is log of 1, it is equal to 0. Therefore we have the final answer as minus log of s divided by square root of s square plus 1, or you could write this to be, you could take this minus sign in the power, so it would be log of s divided by square root s square plus 1 raised to power minus 1, or you could invert this power, so it would be square root s plus square root of s square plus 1 divided by s. So this is the final answer. Similarly, we also have another question. It says that question is, find the Laplace transform of e to the power minus at minus e to the power minus bt divided by t. So now again what will we do? We will first calculate e to the power minus at minus e to the power minus bt's Laplace transform. So it would be Laplace transform of e to the power minus at minus the Laplace transform of e to the power minus bt. Now according to formula, this would be equal to 1 upon s plus a, and this would be equal to 1 upon s plus b. So let us call this as to be f of s. So what is this Laplace transform? This would be integration from s to infinity of f of s ds. So our f of s here is 1 upon s plus a minus 1 upon s plus b into d of s, right? So now again performing its integration, it would be ln of s plus a minus ln of s plus b, and the limits varies from s to infinity. Again you can write this to be s plus a divided by s plus b, and the limits varies from s to infinity. Now also you cannot directly substitute the limits because firstly you would have to divide by s. So when you divide by s both in the numerator and in the denominator, you would have 1 plus a by s and you would have 1 plus b by s, and your limits varies from s to infinity. So when you substitute infinity here, this term would become 0 because 1 by infinity would be 0. So you are left here with 1, and in the denominator this term is also equal to 0 when you substitute infinity as the limit, so it is also 1. And then when you substitute the lower limit, your term would come as such. So 1 plus a by s divided by 1 plus b by s. So what is log of 0? It is 0. And what is this quantity? This you could rearrange. So you would have s plus a divided by s plus b, and then again you can take this minus sign inside, so it would be log of s plus b divided by s plus a. So this is the final answer.